In Chapter 8, we looked at hydrocarbons, which are compounds that contain only carbon and hydrogen. Now we're going to add some personality by adding in other types of elements, and we call these functionalized hydrocarbons. We're going to look at some of those common groups and where we can find those common groups in fats, oils, proteins, and carbohydrates. We'll then dig a little bit deeper into proteins, look at amino acids and essential amino acids, and talk about where the calories come from in food and how to calculate based on the number of grams of fat, carbohydrates, and proteins off of a food label. Then we're going to look at some similarities between combustion and respiration and photosynthesis reactions and how that relates to the foods that we eat. In Chapter 8, we looked at hydrocarbons and talked about alkenes, alkanes, and alkynes. We didn't focus too much on aromatics, but aromatics are structures that contain a ring of carbons with alternating single and double bonds. For functionalized hydrocarbons, we're going to add a few more elements into our structure containing which include oxygen and nitrogen. There's even a few with some sulfur in them. We're going to look at functional groups, and functional groups are combinations of atoms that are linked together in organic molecules. Remember, organic molecules are carbon and hydrogen containing molecules. And the way that these groups of atoms are linked, they're responsible for the characteristic chemical reactions that the molecules undergo. Typically, these functional groups have other elements like oxygen, nitrogen, and even a few have sulfur. When we're looking at functional groups, we've already seen a couple of these. We've seen the alkanes, the alkenes, and the alkynes. You'll notice that we've added in the way that we show these functional groups, some R groups. So these R's represent carbon containing or hydrogen containing groups, and they can change. That's why we represent them as R, just showing an extension of the molecule. The reason there's 1s and 2s is that the 1s and 2s are to represent they're potentially different carbon extensions coming off the molecule. This particular graphic gives you lots of good information about naming. So we've already learned that the ending for our alkanes, the single bond containing carbon atoms, ends in ANE. For an alkene, it ends in ENE, and for an alkyne, it ends in YNE. When we're looking at additional types of functional groups, we also have different endings that we add to the molecule. So if it is an alcohol, we add an OL. So our example here is eth, which means 2 carbons. An means they're singly bonded. And then we change the ending to OL to tell us that we have an oxygen attached to a hydrogen. So our ethers, our ethers have an oxy and an ane in the name. For our example, we have methoxyethane. And an ether is an oxygen that is located between 2 carbon-containing groups. Epoxides are a little triangle ring that contains an oxygen. Haloalkanes that contain a halogen like chlorine or bromine or fluorine. Aldehydes are carbon double bonded to an oxygen with a hydrogen, and the ending to an aldehyde is Al. Ketones are a carbonyl group, and we'll talk more about carbonyl groups, but carbon double bonded to an oxygen between two R groups, 2 carbon containing groups, and they end in the ending ONE. Carboxylic acid is going to be an important group for us to look at, and those end in oic acid. So ethanoic acid would be 2 carbons singly bonded to each other with this carbon double bonded to an oxygen bonded to an OH group. So oic acid tells us that it is a carboxylic acid. Acid anhydride, the name ends with oic anhydride. If it's an ester, carbon double bonded to an oxygen, and then 2 R groups. An amide, which we'll look at a little bit further, ends in amide with the ending of the name. And again, it's a carbonyl group bonded to a nitrogen and 2 hydrogens. An amine, the name ends in amine. And this tells us that it's nitrogen bonded to 2 hydrogens. Nitrile, and the ending is a nitrile. And these are the more common groups that you're going to see. So it's not essential. We're not going to do lots of naming here. It's more of a recognition that we changed the name to match what these functional groups are in organic chemistry. The ones that we're going to be focusing on when we're talking about different foods are our alcohol groups, our carboxylic acid groups, the amide groups, and the amine groups.